Hello viewers, I am Badrinathan, Professor of Mechanical Engineering and Dean Education Development at Sri Venkateshwara College of Engineering, Sri Perumbudur, near Chennai in India. So I welcome you to this lecture series on the topic Industrial Robotics. Basically this course is offered to final year engineering graduates of Anna University as an elective subject, and this is also offered as an elective for Masters in Engineering of Computer Design students and Mechatronics Engineering students as elective subjects. So with this introduction, let's get into the subjects, and before getting into the subject, let's first look at the various objectives which you need to meet and which I need to commit, which you will achieve at the end of this course. So the first objective is to understand the fundamentals of robots and robotics. So basically they are understanding the necessity for a robo and different types of robo, and if there are different types, do we classify them, how do we classify them? So all those things will be one of the basic objective of this program. The second one is about studying the various types of end effectors. Basically when you buy a robo, the robo comes without a hand, and we need to attach a hand to the robo, and that's called an end effector, and the type of hand depends upon what's the application for which you're going to use the robo. And next is about robot kinematics, because I told you the applications for robots is varied. So for different applications there will be different designs needed, and how is going to be the kinematics of those robots, so that we'll cover in this course. Next is about studying about various types of sensors and machine vision system. So when we talk about sensors, I need not emphasize much, because you know that the buzzword around the industry is about Industry 4.0, and this Industry 4.0 is not possible without advanced sensors. And now coming to the machine vision system, because vision system in general, now all of you are aware that the autonomous vehicles are become reality, and without an advanced vision system this is not possible. Of course here we'll see with respect to the context of industrial robotics how our machine vision system will help robot perform its task at the next level. And the next is to obtain the knowledge in robot programming and artificial intelligence. Because when we talk about programming, we cannot generally say that this is the program which is being used for a robot, and there is no generic language, because there are various manufacturers, and each one have their own way of programming the robot. But basically what we will see here is what are the basic methods, various types of programming a robot. And next is about artificial intelligence. Of course again I need not tell much about artificial intelligence, because the buzzword across the globe is artificial intelligence, and across domains, starting from your own personal life, day-to-day life, to the most complex systems, everything is AI driven. And of course that's a big ocean, and what we'll be doing here in this course is we'll see that part of artificial intelligence which will help our robot to perform its task more efficiently and effectively. And next is about robot self-design. Basically, even today robots are fairly costly. So how do we optimize on the investment on robotics? So that's what we are going to discuss about in robot self-design. So with this brief introduction, we'll go further, and I am coming back to the reference books which you can refer to. Of course, the first one by Michael Groover, Industrial Robotics, Technology, Programming and Application. That's one book which covers most of the content of, the typical syllabus. And Robotic Engineering, an Integrated Approach by Richard D. Clapton. Although that's again another a good book which you can refer to, a simple book which has got a lot of information, not only with respect to robotics but also with respect to robotic engineering. But there are two things. When we say industrial robotics, it's more of application oriented. When we say robotic engineering, it's more of design oriented. So this book, Robotic Engineering by Richard Clapton, deals more with engineering than with applications. Of course the next is by Robotics, Control, Sensing, Vision, Intelligence by Fu and Gonsalak. This focuses more on control, vision and intelligence. And again, Yoram Koren, it's again a standard book which deals about robotics. And of course, we talked about machine vision system where we talk about image processing. So a book by Janik Raman which will cover those portions. So now, of course, I think most of you are aware about this outcome-based education. So at the end of this course, what all should be the outcomes of what you have learned? So that course outcomes, which is shortly called as a CO. So let's see what are the outcomes that you need to meet, measure and find out whether you are met or not. So the first one is the student will be able to select a particular type of robot based on the requirement, because I mentioned that there are different types of robots. So based on my requirement, which type of robot should I go in for? And solve problems in forward and inverse kinematics. Of course, I mentioned about the kinematics part of it. So I must be able to solve the problems in that. So that will be one of my outcomes. And the second is to select a suitable drive system. Of course, how do you make the robot work? There are different drive systems, and based on my requirement, I must be able to select a suitable drive system. And also, I mentioned that a typical commercial robot comes without a hand, and I need to attach a hand. And the design of the hand varies depending upon my application or requirement. So I must be able to select a suitable one. And the third one is appropriate sensors. Again, when you say sensors, there are so many types of sensors, and I must be able to understand their various functions and features and select one which will be most appropriate to my requirement. And similarly, a suitable vision system, I must be able to choose a suitable vision system. And next is about selecting a suitable robot cell layout for various needs and perform cycle time analysis. I was mentioning that robots are costly, and I need to optimize on the number of robots that will be installed or commissioned. And how do I go about that? That's my fourth course outcome. And choose the right problem solving technique using artificial intelligence. Of course, one of the most important application of artificial intelligence is problem solving and decision making. So you must be able to pick out the right way of problem solving using artificial intelligence. So robotics. What is a robot? Right? It's an interesting question. Suppose I ask you this question: what do you understand by the term or the word robot? So what answer will you give? Probably someone will say it's a machine which looks like a human, and that's what a human can do, and much more than that. And someone might say something is being done automatically, right? So most of you will give a different answer, but don't go too much technical into that. In the very basic sense, when I say robotics, you can simply say something is being done automatically, right? If something is being done automatically, can be called as a robot. There are so many applications in the day-to-day life where things are being done automatically. Say for example, you have a CNC machine. Of course, you do the programming, and after the program is being checked, you close the door of the machine and then start executing it. And the entire operation is being done automatically without human intervention. Why don't we call that as a robot? So I'll give you another very simple example. Most of you might have gone to shopping malls or big multi-speciality hospitals, where in the entrance, so there is a door which opens automatically. The moment you go near to the door, it opens, and after you cross, it comes automatically. So it's being done automatically. Can we call that as a robot? Right? So then how do we differentiate? There are so many automated machines and the one which we typically call as robot. So we'll come back to the example of CNC machine. A huge program is written and a very complex shape is designed, and without human intervention it's 100% automated, right? How do we differentiate this and a robot? So if something goes wrong, see, you have, check the program and executed it. Something goes wrong in the machine during the execution of the program. What will the machine do? Can it do anything? Something goes wrong. Can the machine react to those errors or mistakes and correct itself? No. So it cannot take any decision on its own. It goes as per the program. When something goes wrong, of course, at the minimal level of intelligence, maybe the machine can stop. Otherwise, in a normal CNC machine, it will just try to execute it blindly, whatever has been programmed into it. And end of that, something goes wrong, it will damage the tool, the machine, the workpiece. Right. So, to put it simply, all those automated systems, machines, mechanisms, whatever you call, they lack in intelligence. Whereas, when you talk about robot, it has intelligence built into it and it will be able to take decisions on its own. So that is the basic difference between any automated device and a robot. So before going into the subject, let's look at robotic history. So I wanted to tell you this because why, with so much of advancements in technology, still robot has not become a very common thing. Of course, it's the rate at which it penetrates is increasing, but still it's not very common. Why? So now if you look at that, in 1922, a Czech author, he wrote a story, and in that story he introduced the word robota, meaning a worker. Right? So normally when we employ servant maids or workers, we want them to blindly work. Whatever instruction we give, they should keep on working without questioning us. They should not take rest. They should not ask for salary increase. No leave, nothing. So he imagined something called a robot, which will blindly obey the orders of its boss or the owner and then do it. So that's where it started in 1922. But one more thing which I wanted to tell you is, see, the idea was not conceived by an engineer. The idea was conceived by a fiction writer. So this one information I thought I should add, because so another important reason is, as an engineer, when you look at a problem, immediately you bring in all the theories into that and try to think something complex design. And you say no, there is a constraint, practically it's not possible. Whereas the writer, he doesn't have any constraints. All that he puts his imagination and whatever comes to his mind, he just writes it. But fortunately, over a period of time, we engineers take it as a challenge. Think, why can't we make it as a reality? Then we start working on that and then make it a viable product. So next, 1954, the first programmable robot was brought in. Just look at the time gap between the time an idea was conceived and the idea was materialized. So it's roughly 32 years or more than 3 decades it took for an idea to come out into a product. And in 1962, although the first programmable robot was made in 1954, the first industrial robot, commercial robot, came up only in the year 1962 by Animation. Animation, again, they are one of the pioneers in robotic technology. So it took another how many years? 8 years. And finally, 1973, Cincinnati Milacron, they are also into all these automation and automated systems. So a model called T3 model robot, which was launched in 1973, which became very popular in the industry and where people started thinking of robotics as a technology which is implementable. Now, of course, I told you, there are a lot of confusions, like somewhere it's automated, but we don't call it as a robot. So the CNC machines, there are so many such things. Then how do we designate something as a robot? So there should be some definition, and your device, instrument or machine or whatever it is, if it fits into this definition, then yes, you can call mine is a robot. So let's see what's the definition we can give for a robot. Of course, we have Robotic Industries Association, and they have defined robot as a reprogrammable. So I mean, CNC machine also now we load different programs. A reprogrammable, multifunctional. So that's a key word there. You cannot buy a robot and say that it will do only this particular job. So it must be able to do multiple functions. So a multifunctional manipulator designed to move, could be materials, raw materials, could be parts, or could be tools, or any specialized devices through variable programmed motion for variety of tasks. So if you look at the definition, it will tell you the complexity of this robot. Reprogrammable, multifunctional, variable program, variety of tasks. So only when your device or whatever it is meets this thing, then you can say this is a robot. So later on, ISO also brought in some definition for robots and robotic devices. Let's see what's that definition. A slight variation of that: an automatically controlled, obviously, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes. These are few things at the later stage. They added 3 or more axes, which may be either fixed in place or mobile for use in industrial automation applications. So normally when you say robot, typically an industrial robot, it is stationed in one place. But later on, when technology evolved, they also came out with a mobile robot for various applications. So that's why this definition added that it could be either fixed in place or mobile for use in industrial automation applications. See, of course, it's very specific because in practical life there are so many devices. People say robotically controlled, robotic, all those things. So this is very specific to industrial automation applications. So this is very important to find out whether your device fits into this category. 3 laws by Asimov, right? Probably even the non-technical persons came about this name Asimov, the full name is Isaac Asimov. I don't know, viewers in India, yes, you are familiar with the Tamil movie Endiran, and also the Endiran 2.0 also came into. I guess most of the people in abroad also should have watched that movie. He is the one who there's a song in that movie and where they talk about this Asimov, Isaac Asimov. So he brought in 3 laws. Why do we need laws? What is the law to do with robotics? So generally, any technology, could be for industrial applications or medical applications, any new innovation that's being brought in, you cannot just like that say, I got a research and development laboratory, I have invented this, I will launch it. So you cannot do that before you put into use any new innovation. You must ensure that that device or your innovation or your product should benefit the mankind and in no way harm the mankind or any living being for that matter. So probably you are aware that say for example the cloning technology. So those technology, this cloning technology was invented long back, but they can't implement it directly because that has some benefits, but if you put into wrong use, that will give a disastrous effect on the mankind. So similarly, Isaac Asimov said, you design, make a robot, but ensure that it follows these 3 laws. So now see what are those 3 laws that Isaac Asimov insisted upon. The first is, a robot may not injure a human being or through inaction allow a human to be harmed. So you are very careful here. I'm elaborating a little here because it's very important. Robots should not injure a human by way of functioning. And the additional thing is, no, a human is going to be harmed and it cannot be idle or inaction and thereby allow a human to be harmed. So that is the first law of Asimov. And second is, a robot must obey orders given by humans, probably the robot's boss, except when that conflicts with the first law. Right? A robot is designed to obey my orders, but then I cannot say, hey, Mr. X is my enemy, go beat him. Right? Right? As per first law, it's supposed to obey. It's supposed to obey my orders, but in that process, it is not supposed to go and harm another human being. And the third is, a robot must protect its own existence unless that conflicts with the first and second laws. Of course, you buy a robot and the robot must safeguard itself, right? And in the process of securing its existence, it should not conflict with the first two laws, that it should not go and injure a human. Now again, coming back, relating with Asimov and the movie Indiran, wherein at one stage the villain, he tries to use the robot for wrong deeds. So in the climax scene, you can see that the robot, it dismantles itself. So that is typically the third law, because if there is a possibility that it is going to harm others, it should not exist. So it dismantles itself and then it goes away. Thank you, viewers. We have come to the end of this first session. So I request you to give your valuable feedback, so that I'll be able to correct myself, and end of the day, it will be a benefit for both of us. Thank you. I'll see you in the next session.